In this tutorial we're going to take a look at creating particles represented by pixels that we can plot on our screen. So at the moment I've got this window which just displays a block of colour and slowly cycles through different possible colours. So I'm going to use that later on. I'm going to save that code for a while, but what I want to do now is define a particle class and display those particles on the screen. So let's go to Eclipse and let's create a new class here. So I'll right click the project, go to new class, and I'll call this particle, and I'll keep it in this cave of programming namespace. I don't know if I'll need a constructor and destructor, but let's define them because there's certainly no harm in having them. Let's click finish. I'm also going to define another class here which I'm going to call swarm, and swarm is going to manage a collection of particles. So let's again, I'll give it a constructor and destructor. I'll call it swarm and put it in this cave of programming namespace again. So we've got two new classes here. Now let's go to particle and let's start thinking about what kind of properties a particle will have. So we're going to define some private instance variables here. And I suppose the most fundamental thing about the state of a particle is that it needs an X and Y position on the screen. And now I'm going to make these double, so let's say double, and I'll call this m_x, m to say m_ to say that it's a member variable, just to make that clear, although that's certainly not absolutely necessary. And let's have a double m_y. Now the reason I'm making them double is because even though on the screen we're dealing with individual pixels, so the X and Y location are always integers, I want to be able to change these values gradually and then just sort of round them off to the nearest pixel position. So if I want to change, for example, the X value gradually by adding some small number to it, like 0.01 every time the screen refreshes, of course I can't do that if it's an integer. So although we have to display it at kind of an integral position at a particular pixel, its position may be somewhere between two pixels. We just kind of round it off to the nearest pixel when we actually display it. But having a double position allows us to move it conceptually bit by bit. So, and that avoids having to move it by an entire pixel every time we move it. So we can achieve more of an illusion of smooth movement. So we've got X and Y. That's probably all we really need to start with. Just an X and Y position for the particle, as far as I can think at the moment. Let's go to the particle constructor here, and in the constructor I could initialize the X and Y values, really. So yeah, let's maybe do that. What I'm going to do is I'm going to include standardlib.h, because I want to use a function called rand, like that. And rand returns a random number between 0 and a constant called rand_max. So this returns an integer, and this is an integer, I believe. So this division wouldn't really make any sense. But if I multiply rand by a double, or if I cast it to a double like that, this will then return as a random number between 0 and 1. Now, what I'd really like to do is I'd like to have the particles kind of move within some virtual space, but I don't want that virtual space to be tied to the screen dimensions, because then if I change if I change the size of the screen or something, then the way our program works has fundamentally changed. I want to have the particles move around in some space of a fixed size, some mathematical space, and then we'll map that later onto the screen. So I'm going to initialize the x position of the particle to somewhere between, let's say arbitrarily, -1 to +1. So we can imagine that the particle inhabits a plane with Cartesian coordinates, if you've ever done any maths, where the minimum x and y coordinates are both -1 and the maximum possible x and y coordinates are both +1. And if you've never studied Cartesian coordinates, you might want to just have a look at a page on them, just for sort of 10 minutes or something, just to get the idea, but they're relatively simple. So if I set, this is going to set x equal to something from 0 to 1, but I want it to be from -1 to +1. So let's firstly maybe work on the range there. So if I multiply rand by 2.0, so now we don't need to cast the double because this bit is a double now. We could put brackets around that just to be doubly sure, so to speak. So this should give us a number in the range 0 to plus 2.0. And if I then subtract 1 from that, I think I'm right in saying that we've now got a range of -1 to +1. So firstly I increased the range there, so that instead of being 0 to 1 it was 0 to 2. Then I subtracted 1, which gives us -1 to +1, if I've got this correct. What's the warning there? Bad character sequence. Sometimes I find this happens, and I think I'm somehow typing invisible characters that it doesn't like. I'm not sure how, but yeah, that's fixed that. I just had to delete, sort of underlined a space there, and I just had to delete it and put the space back in again. Maybe I hit the Alt key by mistake or something, but it doesn't seem to stop it compiling though. Let's do the same with y as well. So let's set y equal to some random number from -1 to +1. So that's our particle covered. Now usually what I'd do is I would supply like a get method for x and y, but we're going to have to deal with a lot of particles, and we're going to have to get x and y values over and over again every time the screen refreshes for a huge number of particles. So perhaps it's better to simply make these values public and access them directly. That breaks encapsulation, but we're forced in games and simulations and things like that often to adopt a programming style that's not ideal for the sake of efficiency. So it might be better to make this public. An alternative thing that you often see done is, instead of explicitly declaring this as public, what we could do is, by default in a class, if I write it like this, these will be private by default. But there's also a thing called a struct in C++. And if I just change this from a class to a struct, the only difference between a class and a struct is that the members are public by default. So if I do this, then we know that the intention is to access these directly and that they are now public. So maybe I'll do that. So that's the only difference between a class and a struct, and that's the sort of thing they ask you on interviews as well, is that by default in a class, member variables are private if you don't specify an access modifier. In a struct, they're public by default. And I'm just making them public for the sake of efficiency, although ideally we wouldn't do that. So that's my particle covered. I also need to initialize this random number generator, because I think it returns, as far as I know, it returns the same random numbers in sequence every time, and I'd like it to return different ones every time. And we can do that by going, for example, to main here, and if I include here, include standard lib again, standardlib.h, and using namespace standard. I've missed out there, D there. Then I can call a function here called srand. And srand seeds the random number generator with a number, which makes it produce a different sequence of random numbers every time. And for the seed number, because I need to supply it with some number to seed it with, I can use a function called time, which is found in time.h, I think, but it's probably already included because we've got stl.h. There's no harm in including time.h if it exists. It does kind of change its name from implementation to implementation. Let's just check what the error is here. So there's something there it doesn't like. I'm just going to check the program that I implemented previously in case I've got this slightly wrong somehow. Let's just check where I seeded my time. So somewhere in here I should have seeded my random number generator. Oh yes, there we go. Ah yes, so the time function takes null. It can return the time into a struct that you pass it, if I remember rightly, and this might be wrong, so don't take this as gospel. But we don't want it to do that. We don't want it to return anything other than the number of milliseconds, I think it is, since 1974 or whatever it is, something like that. To be honest, this is one thing that I've got so used to typing that I've stopped wondering what it actually does. Let's close some of these. Null, but you can certainly Google for that if you're interested. But basically, this formula here seeds our random number generator. Okay, so let's leave that and go back to our program. Okay, I'm going to close everything actually so that I don't get confused and open them again here. So that's not even the right program. Here we go. So particle.h. Okay, so we've got our particle now, and now I want a class that organizes the particles, because we're going to have to deal with a massive load of particles, and I'd like some class that can organize them all. So I've got my swarm here that I've created, and I'm going to give this a private member variable here. Let's say that it's, well, if I include here, if I include double quotes, because it's a local include file, particle.h, and I'm using this Kava programming namespace, and then I can say in here particle pointer, let's call this m_p particles, m because it's an instance variable, p because it's a pointer. Then in my constructor here, let's go to swarm.cpp. Probably this is a reasonable place to initialize this. Let's set that equal to new particle array. And how many particles do we want? Well, I can define a constant. Let's call the constant n particles. And let's go to swarm.h and make that I'll make it public just in case we need to use it outside of swarm. Yes, we probably will in fact. Let's say n particles, and let's make that a const static int. And set it equal to some number like 5,000. You might want to make this lower if your computer's a bit slow, but if it is, you'll find that out later on. But let's try 5,000 to start with. So we're going to have 5,000 different particles. And now we mustn't forget in swarm.cpp, in the destructor here, we have to delete m_p particles. And because it's an array, we need these square brackets. So m_p particles. So now we've got a load of particles there. So this is going to allocate memory and also fill that memory with a bunch of particle objects. And when the particle constructor for each particle runs, it's going to assign a different random location to itself. Now I also want to be able to get particles from my swarm. So I'm going to go to swarm.h here and create a public method which returns a particle pointer, and we'll call it, I could call it get particles, or even just particles. Sometimes it's nice to omit the get, but perhaps get particles would be clearer. Let's call it get particles, and I'll actually implement it here in line because it's only going to be a small function, so I'll implement it in the header, and we'll just say return underscore p particles. Now we should think about const a bit here. This particles pointer, we don't want to point it to anywhere else ever. Once we've set it equal to something in our constructor. So why not make it a const pointer to a particle? And when we actually return it, we want to make sure that when we actually get this pointer outside of this class, we want to make sure that the particles that it points at can't be changed. We only want to change them possibly within this class or within the particle class itself. So let's say that this returns a const pointer, in other words a pointer that can't be made to point anywhere else, to a particle that's const. So a const pointer to a particle that's const. So the particle can't be changed either using this pointer that's returned. Let's try that. Let's just build this thing and see if it builds. So I've got an error here. Oh yes, because I signed this in the constructor. Maybe I can't really make it const because I have to change it at least here. So yeah, that's a shame, but I don't really see a clear way around that. So let's get rid of this const actually. Because sorry, not that one, this one, because otherwise we can't even assign it in the constructor. Okay, let's try this. So I think that looks good. Now let's see if we can actually draw these particles. So let's go to main.cpp, and in main.cpp I'm going to declare a swarm somewhere here. Let's declare a swarm. I'll call it swarm, so that the class has an uppercase S. That's the convention I'm following, and I'll make the actual object the same name with a lowercase s. Some people hate this convention, but I quite like it. We've only got one swarm here, and my classes all have an uppercase letter. So the object can just have a lowercase letter there. Then in my while loop here, I need to get a pointer to all the particles I want to draw. Before I do that, let's comment out some code here. Let's comment out the stuff that displays that puts the coloured block on the screen. We're going to use that later, so I'll just comment it out for the moment with a multi-line comment here, /*// and we'll use it later. Now that should hopefully give us a black screen, and hopefully it shouldn't crash or anything. Let's not continue because we've got an error there. So I've got unused variable elapsed, but that's just a warning. We could include that in the comment. We've also got a error unknown type swarm, and that's just because I forgot the header. So let's include here swarm.h. And let's try building it again, see if it builds this time. Whoops, build project. And yeah, it looks fine now. Let's run it, and we get a nice black screen. Okay, so now let's see if we can plot that collection of particles with their random positions. So they won't move at the moment. We can maybe do that in the next tutorial. Quite exciting, but we can at least plot them so we have something that looks like sort of like stars. So what we need to do is we need to loop through all the particles. Let's say for int I equals 0, I less than swarm : n particles. That's the number of particles, I plus plus. Before we do that, actually, we need to say particle. Well, it's actually const particle pointer const. So reading this backwards, const pointer to a particle that's const. let's call this p particles equals swarm.getParticles. Don't use the class name here by mistake. We need the object that we created there. We need to put that semicolon in the right place. Then we can get each particle. So we can say particle, let's call it, equals p particles brackets I. We could call that p particle to emphasize it's a pointer, but I'll just call it particle, I think. So we're getting the individual particles one by one, and now we need to just plot them on the screen using their position. How can we do that? Well, we're going to have to map the particle space, which goes from -1 to +1 on both x and y, to the actual screen space. So if we get, let's say int, let's call this x equals particle.x. Now what do we have to do to x, the particle x from -1 to +1, to map it to a location on the screen? Well, the first thing is we don't want it to be negative, so let's add 1 to it, because that will make it range. Instead of from -1 to +1, now it'll be from 0 to 2. And let's surround that with brackets. And then if we multiply this by, so if it's ranging from 0 to 2, if we multiply it by half of the width of the screen, it's going to range from 0 to the screen width. It has to be half because we're going from 0 to 2. So if we multiply 2 by half of the screen width, we get the screen width. So let's try this. Let's say multiply it by, I think we can use the constant from screen width. I think that should work. Yeah, so we add, oh yes, it's actually not x but m_x. So we add 1 so that the x is from 0 to 2 and multiply by the screen width. I think this should do the trick. The disadvantage of this actually would be that position 0 for the particle, so 0 plus 1 would be, yeah, multiplied by half the screen width, sorry. If the position is at particle 0, we'd like that to be in the centre of the screen, but does that actually work? So the x position of the particle is 0, add 1, it's 1, multiply it by half the screen width. Yes, I think it actually does work. I think this might actually work. let's try it. Let's also get y in the same way. So int y equals particle dot m_y plus 1 to make it go from 0 to 2 instead of -1 to +1. Multiply it by half of the screen height. So screen height divide by, screen height divide by 2, and then hopefully we'll have the y ranging from 0 up to the screen height. Now, one question in my mind is here: could if the particle's actually at 1, then isn't it going to end up actually at the screen width? If the screen width is 600, it's going to be actually at 600. We don't want that, because that's actually off the screen, because the pixels in the screen start numbering at 0. So if you go up to screen width, let's say, then it's actually off the screen. But for our purposes here, it doesn't matter too much, because we've implemented a set pixel function in screen.cpp, which actually checks, let's see, set pixel is in here. Oh yes, we haven't actually done any checking, but we could make this check and make sure that it doesn't plot a pixel that's off the edges of the screen. I think this wouldn't plot pixels off the edges of the screen, because rand divided by rand max would have to actually return 1 for that to happen? Well, yes, that probably could happen actually. Let's take care of this problem rather than agonizing over the exact possible pixel values of particles. Let's simply make setPixel refuse to plot a pixel off the edge of the screen. So we can put a check here. This is in screen.cpp and setPixel. Let's say if x is less than 0 or x is greater than or equal to screen width, or y is less than 0 or y is greater than or equal to screen height, then instead of plotting a pixel, we'll just return like that. So we'll only plot a pixel if it's within 0 to screen width -1, including screen width -1, or y also has to be greater than 0, and it has to be less than screen height. So I think that's good. Now this is inefficient. If you really needed to squeeze a lot of processing power out of your computer, then you would maybe want to think more carefully about exactly what you're plotting on the screen and possibly not do this. But this used to be something that people bothered about more in the early days of games programming, when computers really struggled to produce anything that looked good at all. But now it's a lot more common to have some kind of clipping, as we call it, on the screen, just to make sure that if you try to plot something over the edge of the screen, that it won't plot, because otherwise, if we didn't do something like this, plotting a pixel off the edge of the screen could easily crash your program. So although this is very inefficient, checking this for every single pixel that we plot, maybe it's not a bad idea here. I think our program will probably still run fast enough. Well, I know it will on this computer, and it saves us having to really agonize about the exact values of pixels that we're plotting. So let's go back now to main.cpp. So now we've calculated the positions of the particles. They might be slightly off the edge of the screen, 1 pixel off the edge, but we don't have to worry about that anymore. Now we can use screen.setPixel, and we can put the x and y positions in there. And for the colors for the moment, well, we could use these rather nice colors that we've calculated here. Let's just make them white for the moment though, to maximum 255 for red, green and blue, so that it's easy to see them. And let's finally run this and see if it works. Here's the moment of truth. And then indeed it works, and we've got a sort of star field there. It doesn't really look like a star field, it's a bit ugly, but we're going to make it look a lot nicer later on. One last little thing that we could do here, which might be nice, would be to uncomment these colors, get rid of the stuff that draws, that fills in the entire screen here, and move this above where we're plotting the particles. Format the code and then use those colors to red, green and blue to draw the pixels. Let's try this and see how this looks. So it's not going to look very pretty, but you can see we've got a load of stars if you've got a good imagination, and you might be able to tell from this video that they are in fact slowly changing colour. Okay, so that's it for this tutorial, very long tutorial, but I wanted to get to the point where you could actually see something new. In the next tutorial, what we're going to do is we're going to animate these particles, so even more exciting, and we're going to get them moving around the screen. So until next time, happy coding.